The planet Earth is part of the planetary system with the Sun in its center. As we all know, it is the star we orbit. A relatively small number of stars are located near it by space standards, and their planets are not likely to be as favorable for sustaining life as we know it as our Earth. So far, there seems to be not a hint or indeed the slightest chance of there being intelligent life elsewhere in space. However, there are a number of stellar systems in space whose properties are identical to those of the solar system, and it's been a while since those discovered counted by the dozen. They actually account for several billion in the entire Milky Way. For the past several decades, astronomers all over the globe have been trying to discover at least one that would reveal signs of life. And it was only in the 21st century that science has started to get somewhere in its attempts to find evidence of there being life out there. It was made possible largely thanks to the discovery of the Trappist-1 system. This object is a single star with a planetary system, and there are at least 3 celestial bodies within the habitable zone. Now let's look at it in more detail. The distance between Trappist-1 and our Sun is 39.5 light-years. The object was discovered in the period from 2016 to 2017. This single star is a red dwarf of spectral type M8V. As for its dimensions, it is only 12.1% of our Sun's radius. Just to compare, it isn't in fact much larger than Jupiter. The mass of Trappist-1 is 27,000 times that of our Earth, but at the same time is 0.08 the mass of our Sun. With the average temperature reaching 2500 kelvins, its luminosity is 1900 times weaker in comparison with that of the main star of our system. The orbital period of Trappist-1 is 3.3 days. As for its age, it is 7.5 billion years, which makes it almost 3 billion years older than the Sun. The distance between this star and us is diminishing, as it is slowly but surely drifting towards our system. This object aroused interest largely following the discovery of its planetary system back in 2016, whose 3 components were spotted by transit method with the help of an automated 0.6-meter telescope in the European Southern Observatory, or the ESO, in Chile. The planets were initially dubbed Trappist-1b, Trappist-1c, and Trappist-1d. However, further investigations revealed that the presumed location of Trappist-1d was described incorrectly. Following that, 4 more Earth-like objects were discovered by astronomers with the help of the Spitzer Space Telescope. These were dubbed Trappist-E, F, G, and H. Thus, the total number of planets in the system reached 7, and on the 13th of April 2016, the parameters of these celestial objects were defined in more detail. All the 7 exoplanets are identical to our Earth in terms of their dimensions, with their radii ranging from 0.71 to 1.13 that of our planet. Planets B and C orbit their parent star in the periods of 1.51 and 2.42 days respectively. Initially, according to astrophysicists, both of these planets were comparable to Venus in all but exceptionally high temperatures. However, after their mass and density had been measured, it was Trappist-1 that could be called Venus's analog. Trappist-1b, the second closest planet to its star, is likely to contain a large amount of water and other volatile elements. The new data enabled scientists to find out more about the other discovered planets too. It takes Trappist-1d 4.05 days to orbit its star. Its radius is 0.77 that of the Earth. The orbital period of Trappist-1e is 6.1 days. Its radius is 0.92 that of the Earth. The orbital period of Trappist-1f may last up to 9.2 Earth days. Its radius is 1.04 that of the Earth. The orbital period of Trappist-1g is 12.3 days, and its radius is 1.13 that of the Earth. Last but not least, Trappist-1 H is the seventh object and is the furthest from its star, with a rotation period of 18 days and a radius of 0.7 that of our planet. It should be mentioned that the initial estimates of the object's masses were likely to be rather conservative. Due to the analysis of the density of the first 6 planets, it was later ascertained that they contain a big amount of water and other volatile elements, which makes them considerably lighter than thought previously. As for the furthest of them, E, F, G and H, for all we know they may consist entirely of water. Only Trappist-1 C boasts a mass bigger than initially estimated, which may be indicative of over 50% of iron in its composition. Of the 7 planets known to be located in the Trappist-1 system, 3 of them find themselves within the habitable zone, namely D, E and F. Speaking about the rest of them, following the estimates of its density, planet B is thought to contain either a small nucleus or else a considerable amount of volatile elements. Due to high temperatures of 127 and 69 degrees Celsius above zero on the surfaces of planets B and C respectively, water is not likely to remain in its liquid state there and is bound to float about as vapor. As for planets G and H, they are too remote from their central star to be potentially habitable. However, according to models suggested at Cornell University, the habitable zone of Trappist-1 may well be wider, and allowing for volcanic hydrogen potentially acting as a greenhouse gas, there may be 4 planets within the habitable zone rather than 3. The density of Trappist-1 F is rather low too, and so it may well turn out to be an all-ocean planet. Here are the temperatures for all the planets in the system. The steady-state temperatures are given without including incident light dispersion and greenhouse effects. Just to compare, the steady-state temperature on our planet in the same conditions would measure 4 degrees above zero, and on Mars 47 degrees below zero. In November 2017, it was posited that the activity of the star didn't allow its planets to form and maintain their own atmosphere. It is accounted for by the fact that Trappist-1 goes through periods of active flares, which may negatively affect the nearby celestial bodies, and thus render them uninhabitable for living organisms as we know them. Interestingly, the planets are located much closer to each other in comparison to our system's planets. The planet Mercury, which is the closest one to the Sun, is located 0.39 astronomical units from it, while the distance between Trappist-1b and its parent star is just 0.01 astronomical units. As Trappist-1 is a rather dim star, it is no easy matter to explore it. Red dwarfs like that are quite widespread across the universe, accounting for most of the galaxy's stellar matter. Plasma ejections on these stars are a rare occasion, although astronomers believe that there may be giant cold areas and compact hot areas with temperatures upwards of 4000 kelvins on the surface of Trappist-1. If this conjecture proves to be true, scientists will proceed to confirm that the system's planets are constantly bombarded by powerful ultraviolet and X-ray radiation, which is able to destroy their atmospheres and render their surface completely sterile. The reason for that lies in the fact that none of the microorganisms known on the Earth are able to withstand intensive radiation emanating from flares of this kind, including the most radiation-resistant bacteria Deinococcus radiodurans. Nevertheless, in December 2017, atmosphere was proven to persist even in periods of high activity of stars, which implies that planets G and H may potentially have their own atmospheres. At the moment, astrophysicists' idea is to use more up-to-date telescopes for studying the matter. For example, the James Webb Space Telescope, whose launch is planned for March 2021. Today, the Trappist system presents a great interest for the global scientific community, and even though it is highly unlikely that any advanced civilization will be discovered on its planets, we cannot ignore the fact that life forms in the universe may be extremely diverse and may differ from our perceptions of life as we know it, which implies that not all intelligent organisms are supposed to follow the scenario of our planet. If science manages to find out more details about this system in the nearest decades, many conjectures and doubts we have today about Trappist-1 will most likely be cleared. Every new object of the kind discovered by scientists heralds yet another leap forward by our civilization, and it's a pleasure for me to be telling you about it. Thanks to your support when you like our videos and leave your comments, our project keeps growing, and I'm really grateful that you help the Kosmo channel to improve. I hope that we will soon be able to have the pleasure of sharing some more information about this fascinating stellar system, because the process of its exploration is only just starting. Let's keep in touch.